This is SpaceTime Series 20, Episode 69. Coming up on SpaceTime, the final countdown to Cassini's mission end, NASA's next Mars mission to investigate the red planet's interior, and the first ever launch of a Minotaur 4 rocket from Cape Canaveral. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
On September the 15th, NASA's Cassini spacecraft will finally end its historic mission to the ringboard of Saturn and its many moons. During its 13 years of groundbreaking observations, Cassini has changed science's understanding of the Saturnian system. Its observations of Saturn, its rings and entourage of more than 62 moons has provided enough data to fill more than 4,000 scientific papers. Cassini is now undertaking its final series of 22 so-called grand finale orbits, designed to bring it ever closer to its ultimate demise. These orbits take the 2,150-kilogram minibus-sized probe through the gap between Saturn's inner rings and the planet's swirling cloud tops. Cassini's final orbit on September 9th will send it through the outermost fringes of Saturn's atmosphere, passing just 1,680 kilometers above the clouds. 2 days later, on September 11, Cassini will make a 119,049-kilometre flyby of Saturn's largest moon, Titan. The gravitational perturbations caused by the Titan flyby will slow down and reposition the spacecraft for its final descent deep into the planet's atmosphere. Cassini will take its final images of Saturn on September 14, sending back its last look at the moons Titan and Enceladus, as well as that weird hexagon-shaped vortex around the planet's north pole and strange propeller pattern features in the Saturnian rings. The spacecraft will then turn its antenna towards Earth and begin a communications link that will continue until the end of the mission. Cassini will also use these final hours to undertake detailed high-resolution observations of Saturn's aurora and monitor temperatures and pressures before being configured for entry into Saturn's thick atmosphere. Finally, during the early hours of September 15th, Cassini's suicidal death plunge will send it into Saturn at over 120,000 kilometers an hour. With its 12 science instruments running, Cassini will continue transmitting near real-time data back to Earth as it travels deeper and deeper into the gas giant's hydrogen, methane and ammonia atmosphere. Cassini's final act will begin at 4:37 in the morning US Pacific Daylight Time. That's 21:37 Australian Eastern Standard Time and 11:37 in the morning Greenwich Mean Time, as the spacecraft begins a 5-minute roll maneuver designed to position its ion and neutral mass spectrometer for optimal sampling of the atmosphere and for transmitting that data back to Earth in near real time. Cassini project scientist Linda Spilker from NASA's Jet Propulsion Laboratory in Pasadena, California, says directly sampling the atmosphere's composition could provide new insights into Saturn's formation and evolution. Finally, Cassini will enter Saturn's atmosphere at 4:53 in the morning US Pacific Daylight Time. That's 9:53 in the evening Australian Eastern Standard Time and 11:53 in the morning Greenwich Mean Time. The spacecraft's thrusters will begin firing at 10% of their capacity to maintain directional stability as long as possible, thereby allowing Cassini's high-gain antenna to remain pointed towards the Earth so that data can be transmitted to NASA's Deep Space Communications Network. However, just a minute or two later, Cassini's thrusters will be firing at 100% capacity as Saturn's atmospheric forces overwhelms the thrusters' capabilities to maintain control of the spacecraft's orientation. As this happens, Cassini's high-gain antenna will lose signal lock with Earth, cutting all communications and bringing Cassini's historic mission of exploration finally to an end. Mission managers expect that to occur about 1,510 kilometers above Saturn's cloud tops, as the planet's thick, crushing atmosphere destroys the spacecraft, ripping it to pieces and turning the blackened debris into fiery meteors. NASA's decision to end Cassini's mission with a suicidal plunge into Saturn's atmosphere is based on the administration's prime directive to limit possible Earth microbial contamination as much as possible. With Cassini's fuel supplies running low, NASA wanted to ensure the probe doesn't crash onto any of the Saturnian moons that could possibly harbour life. Burning up the spacecraft in Saturn's atmosphere will limit the contamination any surviving hitchhiking Earth microbes could cause. Cassini's final dive will end an historic mission which provided new insights into the worlds of the outer solar system. It's included stunning views of three-dimensional structures towering high above Saturn's rings, and a giant Saturnian storm which circled the planet for almost a year. And even during these grand finale orbits, Cassini's science mission continues. These final 22 orbits are venturing into a previously completely unexplored region of Saturn, allowing Cassini to provide unprecedented observations of the planet's rings and magnetic and gravitational fields. These observations have already shown scientists that Saturn's spectacular ring system has far less mass than expected. And that suggests they're far younger than previously thought, possibly as little as 100 million years old, and most likely the result of a moonlet being ripped apart by Saturn's gravity as it passed inside of Saturn's Roche limit, or through collisions between moonlets, or a combination of both. Scientists have hypothesized that if the ring system was more massive, then it would be older, because its combined gravity would have held it together better, preventing it from being gradually eroded away over time through meteoroid collisions. But because Saturn's rings are a relatively recent addition, it means we're seeing Saturn at a rather unique time in its evolution. Cassini was launched on October 15, 1977, aboard a Titan 4B Centaur rocket from the Cape Canaveral Air Force Base in Florida on a 7-year mission to the Saturnian system. Controversy surrounded the launch, with protesters concerned about Cassini's plutonium-238-powered RTGs, or radioisotope thermoelectric generators, needed to power the spacecraft system so far from the Sun. However, those initial fears of radioactive fallout if the launch failed, or if the Earth gravity assist flyby 2 years later went wrong, quickly faded into the background as Cassini continued its pioneering journey without incident. As well as the Earth flyby, Cassini also used gravity assists of both Venus and Jupiter to help slingshot it towards Saturn, achieving Saturn orbit insertion on July 1, 2004. 6 months later, on December 25, 2004, Cassini deployed its European Space Agency Huygens lander, which descended through the thick atmosphere of the mysterious Saturnian moon Titan, long considered to be a primordial version of the Earth. Huygens touched down on January 14, 2005. This was the first ever landing on the surface of a world in the outer solar system. The surface of Titan where Huygens landed was later described as being like cold, wet sand. What makes Titan so fascinating is that it's the only place in the solar system other than Earth where it rains, forming rivers which then flow into lakes and seas. Recent observations have also discovered that complex prebiotic chemicals form in Titan's atmosphere, which then rain down onto its surface. Of course, the surface of Titan's so cold, water is frozen, forming much of the moon's bedrock. So instead of water, the liquids on Titan are hydrocarbons, methane and ethane. But Cassini did find oceans of liquid water below the frozen, icy crust of another Saturnian moon, Enceladus. Plumes of water were found jetting out from geysers dotted across the spectacular tiger stripe formations of the Enceladian South Pole. And readings by Cassini indicate that, like the Jovian ice moon Europa, the Saturnian ice moon Enceladus has a global subsurface liquid water ocean beneath its frozen crust. And minerals detected in those plumes of water indicate the likely presence of hydrothermal vents on the subterranean seafloors of Enceladus. On Earth, seafloor hydrothermal vents thousands of meters below the surface host ecosystems rich in life. And there's a growing view among biologists that life on Earth may even have begun in the nutrient-rich chemical soups around these vents. And that raises the possibility of similar processes taking place around the hydrothermal vents of Enceladus and Europa. During the solar system's 4.6 billion year history, Mars and the Earth have consistently swapped rocks. And so, if evidence of past or present life is eventually found on the red planet, it could well simply be the result of meteorite contamination from Earth. However, if life is found to exist in the distant frozen worlds of Enceladus and Europa, then it would most likely have arisen independently from that on Earth, a prospect which raises the very real possibility of life being common throughout the universe. You're listening to Space Time. I'm Stuart Gary. Preparations for NASA's next mission to the red planet Mars are ramping up, on course for launch in May. NASA's InSight lander will launch from the Vandenberg Air Force Base in California, the first ever launch of an interplanetary mission from America's West Coast spaceport. Lockheed Martin's currently assembling and testing the InSight spacecraft in a cleanroom facility near Denver, Colorado. Lockheed spacecraft program manager Stu Spath says the lander's completed and its instruments have been integrated, allowing technicians to complete final spacecraft testing, including acoustics, instrument deployments, and thermal balance tests. InSight is the first mission to focus on examining the deep interior of Mars. In fact, the InSight acronym stands for Interior Exploration using Seismic Investigations, Geodesy, and Heat Transport. No wonder they called it InSight. The information gathered will boost science's understanding of how the rocky planets, including the Earth, form. InSight Principal Investigator Bruce Bannett from NASA's Jet Propulsion Laboratory in Pasadena, California, says because the interior of Mars has churned much less than the Earth's in the past 3 billion years, the red planet could preserve evidence about the infancy of terrestrial worlds better than the Earth does. InSight's 5-week launch window begins on May the 5th, 2018, with Mars being close enough to Earth for a flight time of just over 6 months. The best planetary geometry for launches to Mars occurs during opportunities about 26 months apart, lasting only a few weeks. That's what led to the May 2018 launch date. The mission will place the stationary lander near the Martian equator. Once on the ground, with the 2 solar panels unfolding like paper fans, the lander will span some 6 meters. Within weeks of landing, always a dramatic challenge on Mars, InSight will use a robotic arm to place its 2 primary instruments directly and permanently onto the Martian ground, an unprecedented set of activities on Mars. These 2 instruments include a seismometer and a heat probe. The seismometer, supplied by the French space agency CNES in collaboration with the United States, the United Kingdom, Switzerland and Germany, will be shielded from wind and have enough sensitivity to detect ground movements just half the diameter of a hydrogen atom. It will record seismic waves from Mars quakes as well as meteor impacts, information which, like seismometers on Earth, will help reveal a great deal about the red planet's internal structure. The other instrument, the heat probe, will hammer itself more than 3 meters into the Martian ground, where it will measure the amount of energy coming up from the planet's deep interior. The heat probe was supplied by the German Aerospace Centre DLR, with the self-hammering mechanism coming from Poland. A third experiment will use radio transmissions between Mars and Earth to assess perturbations in how Mars rotates on its axis. This will provide clues about the size of the red planet's core. The mission's launch was originally slated for March 2016, but it was called off due to a leak in a metal container designed to maintain near vacuum conditions around the seismometer's main sensors. A redesigned vacuum vessel for the instrument was then built and tested, then combined with the instrument and other components and tested again. The full seismometer instrument was only delivered to the Lockheed Martin spacecraft assembly facility in Colorado in July and was then installed on the lander. Together with 2 active Mars rovers, Opportunity and Curiosity, as well as 3 NASA Mars orbiters and a Mars rover now being built for launch in 2020, the InSight mission forms part of a legacy of robotic exploration to the red planet, helping to lay the groundwork for ultimately sending humans to Mars during the 2030s. You're listening to Space Time. I'm Stuart Gary. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. And time now to turn our eyes to the skies as we look at Skywatch for the month of September. September was the 7th month of the old Roman calendar, which had just 10 months before the addition of January and February. And that 10-month year is still reflected today, with the names September or Septem being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. This month also marks the September Equinox, which will take place at 6:02 in the morning Australian Eastern Standard Time on Saturday, September 23rd. That's 8:02 in the evening, September 22nd, Greenwich Mean Time. The equinox marks the point in Earth's orbit around the Sun, when Earth's rotational axial tilt means the Sun will appear to rise exactly due east to someone standing on the equator and set exactly due west. It means almost equal hours of darkness and light. In fact, the word equinox is derived from the Latin, meaning equus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun. Earth's axial tilt is pointed to the same position in the sky regardless of Earth's orbital position around the Sun. On other days of the year, either the northern or southern hemisphere are tilted more towards the Sun, but on the two equinoxes, usually around March 21st and September 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. For those in the northern hemisphere, it means the start of fall or autumn, while those south of the equator move into spring. However, there's a complication. For some strange reason, Australia starts its seasons on the first day of the month rather than on the solstice season equinoxes. So that means spring in Australia officially begins today, September 1st. It's also worth noting that the solstice season equinoxes change over time, impacted by something called precession, which causes the Earth's spin axis to wobble ever so slightly, like the axle of a spinning top. The rate of precession is only about half a degree per century, so people don't notice it in a human lifetime. Because the direction of Earth's axis of rotation determines which point in Earth's orbit the seasons occur, precession will cause a particular season, for example the southern hemisphere's spring, to occur at a slightly different place from year to year over a 21,000-year cycle. At the same time, Earth's orbit itself is subject to small changes known as perturbations. The Earth's orbit's an ellipse, and there's a slow change in its orientation, which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. The two effects, precession of the axis of rotation and a change in the orbit's orientation, work together to shift the seasons with respect to perihelion. Because we use a calendar year that's aligned to the occurrence of seasons, the date of perihelion gradually regresses through the complete 21,000-year cycle. Okay, let's start our tour of the September night skies by looking to the east and the constellation Capricornus, the goat. The name comes from the ancient Greek tale of the demon Typhon emerging from a fissure in the earth and attacking Zeus, the king of gods, during a banquet. Overcome by cowardice, the flute-playing goat boy Pan tried to escape by turning himself into a fish and swimming away. However, courage finally overtook him before he completed his transformation, and he distracted the demon by playing his flute, giving Zeus enough time to use a thunderbolt from the heavens to frighten Typhon away. Because of his actions, both cowardice and brave, Zeus placed Pan in the skies forevermore, still in his half-goat, half-fish guise. The brightest star in Capricornus is Delta Capricorni, also known as Deneb Algedi or the tail of the goat. It's located about 39 light-years away. Deneb Algedi is a spectrotype A white Beta-Lyra variable eclipsing binary comprising two stars closely orbiting each other. The total brightness of the system changes because the two component stars periodically pass in front of each other as seen from Earth, thereby one star periodically blocks out some of the light coming from the other star in the system. The two component stars of Beta-Lyra systems are massive giants or supergiants, so close to each other that their shapes are heavily distorted by their mutual gravitational forces, giving them ellipsoidal shapes with extensive mass flows from one component star to the other. Just below Capricornus on the eastern horizon, we find the constellation Aquarius, the water carrier to the gods. Greek mythology describes Aquarius as the most stunningly beautiful-looking youth that ever lived. He was so good-looking that he was carried up from Earth to Mount Olympus by the god Zeus in the guise of Aquila the eagle, where he was made water carrier and cupbearer to the gods. The two brightest stars in Aquarius are Alpha and Beta Aquarii, a pair of luminous red giants nearing the end of their lives. They were once massive spectral type B blue-white stars. The pair are now moving through space perpendicular to the plane of the Milky Way. Beta Aquarii, the brightest of the pair, is also known as Sadal Sud. It's a multiple star system located 540 light-years away. The primary star has about 6 times the mass of the Sun, but emits roughly 2,300 times the Sun's luminosity, implying a radius at least 50 times that of the Sun. Beta Aquarii appears to have 2 faint companion stars, but you'll need a decent-sized telescope in order to see them. The second brightest star in Aquarius is Alpha Aquarii, also known as Sidal Melek. It's about 520 light-years away and has about 6.5 times the mass of the Sun and about 3,000 times the Sun's luminosity, again implying an incredibly massive radius. Next, we move to the southern constellation of Pisces Austrinus, the southern fish. The brightest star in the constellation is Fomalhaut, the mouth of the southern fish. It's also the 18th brightest star in the sky. Thousands of years ago, Fomalhaut used to mark the position of the winter solstice, the sun's most southerly position as seen from the northern hemisphere. However, the precession of the equinoxes, which we mentioned earlier, has now moved the northern winter solstice to its new position in December. Located only 25 light-years away, Fomalhaut is a spectral type A white-yellow star, about twice the mass of the Sun and about 16 times the Sun's luminosity. It's also a relatively young star, only 400 million years old, compared to the Sun's 4.6 billion years. Interestingly, Fomalhaut exhibits an excess of infrared radiation, indicating it's surrounded by a circumstellar disk. It's also part of a triple star system, together with a spectral type K orange dwarf star, TW Pisces Austrinus, and a spectral type M red dwarf star, LP876-10. Turning to the north now, and we find the constellation Pegasus, the fabled winged horse of Greek mythology. Pegasus was the one who delivered Medusa's head to Polydectes, after which he travelled to Mount Olympus to become the bearer of thunder and lightning for Zeus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, which marks the horse's muzzle. Almost 12 times the mass of the Sun, it's an orange supergiant nearing the end of its life. Astronomers are still debating whether it will end its days as a core collapse supernova or as a rare neon oxygen white dwarf. Also visible in the north is the constellation of Cygnus the Swan, the home of Cygnus X1, the first ever suspected black hole. The constellation lies on the plane of the Milky Way. Cygnus contains the star Deneb, one of the brightest stars in the night sky and one corner of the summer triangle. It's also home to the giant stellar association of Cygnus OB2, which includes NML Cygni, one of the largest known stars, a red hypergiant with some 1,183 times the radius and 50 times the mass of our Sun. In fact, it's so large that were it placed where the Sun is at the centre of our solar system, its visible surface would extend beyond the orbit of Jupiter, containing a volume equivalent to some 1.6 billion times that of the Sun. Luckily for us, NML Cygni is located some 5,300 light-years away. As we mentioned earlier, also located in Cygnus is Cygnus X1. It's a powerful galactic X-ray source which became the first widely accepted black hole. It was discovered back in 1964 and remains among the most studied astronomical objects in the sky. The black hole at the heart of Cygnus X1 is estimated to have about 14.8 times the mass of the Sun, all crammed inside an event horizon with a radius of just 44 kilometres. Located just above the northern horizon right now is Vega, the brightest star in the constellation Lyra and the fifth brightest star in the night sky. Vega has about twice the mass of the Sun. It's also a relatively young star, less than 500 million years old, and is located about 25 light-years away. Due to precession of the Earth's rotational axis, Vega, rather than Polaris, used to be the northern pole star around 14,000 years ago, and it will do so again in another 12,000 years' time. Just above Vega is Alpha Aquilae, or Altair, the brightest star in the constellation Aquila. It's a spectral type A white-yellow star about twice the mass of the Sun and located about 16.7 light-years away. Altair rotates extremely rapidly with an equatorial velocity of about 286 kilometres per second, and that's a significant fraction of the star's estimated breakup speed of 400 kilometres per second. Because of its high rotational rate, Altair is not spherical but flattened at the poles. In Greek mythology, Altair is the eye of the eagle that carried Aquarius up to Mount Olympus to become the water-bearer to the gods. Okay, let's turn to the southeast now, and there you'll see the star Archinea, the brightest star in the constellation Eridanus, the river. Located about 140 light-years away, Archinea has some 7 times the mass and 3,000 times the luminosity of the Sun. The star's another rapid rotator. In fact, it spins so quickly on its axis that it's elliptical in shape, with its equatorial diameter about 56% wider than its polar diameter. September also sees the bulk of the Aurigaud's meteor shower, produced as the Earth passes through a debris trail left behind by the comet Kess C1911N1. Kess is a long-period comet which only reaches the inner solar system every 1,800 to 2,000 years. The meteor shower runs between August the 28th and September 5th. The Aurigaud's provides up to 5 swift and bright meteors an hour, with its peak just before dawn on September 1st, which I guess means you've probably already missed its climax. Sorry about that. The Aurigaud's are best viewed from the northern hemisphere, as its radiant, that is the direction the meteors appear to be coming from, lies in the northern constellation of Central Auriga. The second meteor shower of this month is the Epsilon Perseids, which runs from September the 5th through to the 21st. Although they're called the Epsilon Perseids, the radiant actually lies closer to the star Beta Perseus Algol. Also, the Epsilon Perseids shouldn't be confused with the Perseids meteor shower in August, because while they both appear to have their radiant in the constellation Perseus, they're actually caused by debris trails from two different comets. And now, with more of the September night skies, I'm joined by Jonathan Nally, the editor of Australian Sky and Telescope magazine.
Well, Stuart, I'll tell you one thing we don't have this month, and that's an eclipse, because, of course, the big solar eclipse happened last month, and I hope plenty of SpaceTime listeners in the US and other places got a chance to experience it, because it's a pretty amazing thing.
Let's just hope that none of these umbrophiles, I think that's the correct term, isn't it? Umbrophiles?
Yeah.
Let's hope none of these umbrophiles looked at the sun without wearing the correctly approved spectacles for such an event. I'm talking specifically about certain residents at number 1600 Pennsylvania Avenue, who I saw looking at the sun without glasses. He's the president.
Leader of the free world.
And he wasn't wearing his eclipse glasses.
Oh, look, solar eclipses are always amazing. They're always fantastic things.
I'm one of those few umbrophiles who have never actually witnessed an eclipse. Tell me about them.
Well, they're pretty amazing things. They really are. I mean, apart from the fantastic sense of occasion where everyone gets out and wears their proper eclipse glasses and things and has a great old time, it's really, really spectacular. Even when the moon is sort of slowly covering up the sun, even when the sun is still a thin sliver, you're almost at eclipse, there's still enough light coming through that it's daylight still, right? It's only right in the last few moments that all of a sudden it just goes black. And then when it's totality, you are safe to look at it for a short while, and then you just see this black hole in the sky, and you see the corona, like this ghostly sort of cloud all around it, shining there or glimmering there. And it just looks like a hole in the sky. It really, really does. It looks like someone's opened up a hole in the sky, and you could fall through it, or something could come through at you or whatever. It's really quite, and it really, I don't know, I got a real catch in my throat when it happened. It was, when I saw it, it was really, it's quite an emotional occasion. I just don't know why. No one really knows why. And people have studied this, and even thinking back to it now, it just was really, really amazing. And you can see, when you experience one, you can see why people become hooked, and they just want to go from one eclipse to another. And as soon as they've seen one, they're planning the next one, if they aren't already, no matter where it is in the world. And people go to all weird and wonderful places to see the eclipses, because, of course, they can happen sort of anywhere. Siberia, or in the middle of the ocean, or, all over the place. So the United States and surrounding regions were very, very lucky this time to have it so convenient, right through the middle of the country.
Haven't they?
Yeah, but they had a big dry spell there for a while. For us here in Australia, we've got a bit of a dry spell. Our next one's not till 2028, but very similar to the United States one, where it's going to basically cut right through the middle of our country. It's going to start in the sort of top left-hand corner in the northwest of Western Australia and go right through the middle, basically, and go right through the centre of Sydney on the east coast and then out into the ocean. So that's going to be pretty specky. While we're on the topic of eclipses, there are 5 eclipses coming up worldwide next year. There are 3 partial solar eclipses, and there are going to be 2 total lunar eclipses, which is pretty good. So in January 31st, there's going to be a total eclipse of the moon. Now that's going to be visible from Australia and most of Asia. Other parts of the world will only see some of it, but pretty good still. A couple of weeks later, because usually they come a couple of weeks apart, February 15 is going to be a partial solar eclipse. But to see that one, you're going to have to be down there in Antarctica with the penguins, or down the very sort of far south parts of South America. They're going to get to see it. In the middle of the year, July the 13th, there's going to be a partial solar eclipse again. But again, you've got to be, I don't know, a seal or a whale or something, or one of these albatross floating down there in the Southern Ocean, because it's only going to clip the southern edges of Australia and New Zealand. So probably very few people are going to get to see that one, maybe unless you're in Tasmania. A couple of weeks after that, July 27, 28, there's going to be another total eclipse of the moon, which is going to be visible in full from most of Africa, all of India, most of the Middle East, and sort of Central Asia there, and the rest of the world or parts of the rest of the world will see a partial eclipse of the moon. And then finally in August, on August the 11th next year, there's going to be another partial solar eclipse, and to see this one, you're going to have to be in either Greenland or far northern Canada, or sort of northeastern Europe, all of Russia, northeastern Asia, that sort of area. Still, a lot of people live there, of course, so they should get to see that. But no total solar eclipses next year, but we've got 2 total lunar eclipses, so that should be pretty good.
Tell me about September's night skies on Skywatch.
Right, so what's in the sky during September? Let's start with the Milky Way and the constellations. So at mid-evening during September, the Milky Way, which is our home galaxy, of course seen from the inside, is stretching right across the sky from from north to south. Really, really magnificent. If you can get some dark skies, you'll be able to see it all the way across from sort of north down to south around about 8:30, 9 o'clock. For those of us at sort of mid-southern latitudes, temperate latitudes in the southern hemisphere, the centre of the galaxy, the centre of the Milky Way, and the star fields of Scorpius and Sagittarius are more or less directly overhead. Really amazing. This region is really great to view, even if you've just got a pair of binoculars, because you can see all sorts of stuff, even with just binoculars. But try to get away from any nearby sources of light pollution, because some of the things in the Milky Way are faint enough that, street lights and other things can drown them out a little bit. Way down south, the Southern Cross is there. It's lying on its right-hand side at the moment with the two bright pointer stars above it. Now, as far as the planets go, again, from sort of mid-southern latitudes, Saturn is right overhead, right up there in the sort of, just to the one side of the constellation Sagittarius. It's actually in this constellation Ophiuchus at the moment. If you get a chance to look at Saturn through a telescope, please do so.
Waved by to Cassini as well, last month. For Cassini.
Yeah, Cassini's going to be plunging into Saturn. What a fantastic mission that's been. 2004, I think it got there.
2004, and it launched, 7 years before that. So
it's pretty amazing, isn't it? Good value for money. It's a really fantastic, successful mission, and it'll be sorry to see it go, but even in its death plunge into Saturn, they'll still be learning stuff. They'll be getting data back as it goes in and learning more about the ringed planet. So if you get a chance to have a look at the ringed planet through a telescope, maybe you've got one, or a neighbour's got one, or a friend, or there's a local observatory or planetarium nearby, you can have a look. Make sure you do, because it always looks wonderful with its rings. Jupiter is in the western part of the sky after sunset, still fairly nice and high, and again, if you get a chance to look at it through a telescope, you'll be able to see some of its cloud bands and up to 4 or 5 of its moons. And even with a good pair of binoculars, it'll show it as a bright star, and you should be able to see the 4 brightest moons as little pinpricks of light to either side of the planet. You might see 2 on one side and 2 on the other, or 1 on one side and 3 on the other, depending on where they are as they orbit around Jupiter. Now, if you're a morning person, then you'll be able to spot Venus in the eastern pre-dawn sky. You can't miss it. It's big and bright, the biggest and brightest thing out there. Have a look on September the 18th, because Venus and the Moon will be right next to each other, so that'll be a really amazing sight. Mercury, the planet Mercury, the innermost planet, is also in the pre-dawn sky, but very, very low down on the horizon before sunrise, so you'll probably have difficulty trying to find it. But don't worry, there'll be a better opportunity to see Mercury later in the year. Similarly, the red planet Mars has been out of view around the other side of the sun for a while, but it's about to make a reappearance in the pre-dawn sky as well, out to the east, around about the end of September.
I know JPL are looking forward to that, because they've been unable to contact any of their Mars spacecraft for the last couple of months because of that.
That's right. On the other side of the sun, you can't get the radio signals through, so fingers crossed everything's still going well there. So Mars will be reappearing in the early, or in the pre-dawn sky, very, very low down, though, just before sunrise. So, again, it's going to be hard to spot, so be easier in a couple of months' time, so perhaps wait until then. And finally, Stuart, it's September, and that means it's equinox time. This year it'll be on the 23rd. The equinox, of course, is the day when the hours of daylight and darkness are pretty close to being equal. Now, for people in some parts of the world, the equinox signifies the beginning of a new season. So in the United States, for instance, the September
Equinox... In most parts
equinox,
of the world?
Yeah, most parts, yeah. So in the US...
Australia's really weird like that, in that it doesn't celebrate the start of the season on the equinox or on the solstice.
Well, a large part of the population of the world, certainly in historical times, have been at those northern latitudes, where you do get really abrupt change, or not abrupt changes, but very definite seasons, very definite winter, summer, spring, autumn. So September equinox is the beginning of autumn or fall in the United States and other parts of the northern hemisphere. But here in Australia, as you said, the September equinox, we don't take that to being the beginning of the season, and that, Stuart, is what's in the sky for September.
That's Jonathan Nally, editor of Australian Sky and Telescope magazine. And this is SpaceTime. I'm Stuart Gary. A Minotaur rocket has successfully carried out its first launch from the Cape Canaveral Air Force Base in Florida, carrying a new experimental space surveillance satellite into orbit. The Minotaur 4 blasted off from the Cape's Long Dormant Launch Complex 46, carrying the 140-kilogram SensorSat ORS-5 satellite into a 600-kilometre high equatorial orbit.
VM is go for launch.
Checked step 93.
ORS-5.
T-minus 10.
9, 8, 7, 6,
5, 4, 3, 2, 1. Ignition and liftoff of the Minotaur 4 rocket carrying the ORS-5 spacecraft for the United States Air Force.
Goal supersonic. Check step 94, 95, 96, 97.
Vehicle avionics power is nominal.
LC, RCO, countdown net, liftoff, first motion time.
Mach 2, motor pressure nominal.
0.224.
Passing Mach 3 at maximum stage 1 thrust of 534,000 pounds. Passing Mach 4, vehicles half of original mass.
Stage 1 set, stage 2 ignition.
Stage 2 motor pressure is nominal.
Vehicle attitude and flight path are nominal.
BCC power up, G2 cooling.
Hearing the voice of Carl Sealant providing
Vehicle
launch
avionics and power
vehicle
systems
ascent
performing as
data.
expected. GNC cooling off.
Check step 2. Step 1 in work. T plus 85 seconds at maximum stage 2 thrust of 330,000 pounds.
Vehicle attitude and flight path are nominal.
In RCO, have you got AOSJD TMA?
LC, RCO, AOS, JDMTA.
Check step 3. Approaching stage 2 burnout at 115 seconds, followed by a 10-second coast and 2-3 ignition.
Stage 2 burnout.
Stage 2 separation, stage 3 ignition. Stage 3 motor pressure nominal.
Vehicle attitude and flight path are nominal. Vehicle is approaching the stage 3 gate.
Variant separation confirmed.
Vehicle attitude and flight path are nominal.
Plus 3 minutes. At maximum thrust of 73,000 pounds.
Stage 3 burnout. Guidance solution converged. Stage 4 ignition will occur at T plus 831 seconds.
This is Minotaur Launch Control, and as you just heard, we just had third stage motor burnout. The rocket has now entered a 10-minute coast phase. Liftoff was at 2:04 a.m. Eastern Time as the ORS-5 continues on its way to orbit.
The Massachusetts Institute of Technology built ORS-5 satellite is designed to spy on other satellites, watching for unusual orbital maneuvers as well as debris from space junk. The Minotaur rocket is based on surplus intercontinental ballistic missiles, modified by orbital sciences to carry satellite payloads instead of their usual multiple thermonuclear warheads. The smaller Minotaurs 1 and 2 were based on the 20-metre tall LGM-30 Minuteman solid rocket 3-stage missiles. These ICBMs were capable of launching multiple re-entry vehicles with 3 350-kiloton thermonuclear warheads over a range of more than 13,000 kilometres. The larger Minotaurs 3, 4, 5 and 6 used the LGM-118MX Peacekeeper ICBM. The larger 22-metre tall 3-stage MX Peacekeeper also uses solid rocket engines carrying up to 12 individually targeted 350-kiloton thermonuclear warheads at ranges of well over 14,000 kilometres. The Minotaur 4 uses the 3 stages of the MX Peacekeeper, with the warheads replaced by a solid-fueled Orion 38 4th stage for orbital insertion and then a satellite payload on top of that. However, for this ORS-5 mission, an additional Orion 38 was added, giving the stack 5 stages, so it had the power to achieve equatorial orbit. As well as the primary satellite, the ORS-5 was also fitted with 3 smaller CubeSats, which were deployed in orbit. You're listening to SpaceTime. I'm Stuart Gary. And now, time to take a brief look at some of the other stories making news in science this week with a science report. And a new study claims time may be the key to memories. Scientists still don't know how short-term memories become long-term ones. But researchers at New York University think this transition may best be explained by a temporal hierarchy of time windows that collectively alter the state of the brain. Their study, reported in the journal Neuron, claims the manner by which short-term memories evolve into long-term memories is akin to how humans process sound. Much like sound is broken down by the auditory system into many discrete bins of frequencies that are all perceived simultaneously, an experience is processed by the brain into many time windows that collectively represent an image or idea of the past. Most memories last for seconds before they're forgotten, but as we all know, some last a lifetime. The authors hypothesize that at each given moment, both kinds of memories coexist with ongoing experiences on the same terms. Less understood among neuroscientists is how, where and when short-term memories become long-term. For example, does the memory move from one brain storage area to another? Do short-term memories transform into long-term ones over time? And are long-term memories a modified version of a short-term memory? Or are they two totally independent bits of information? The authors believe changes occurring on the fastest timescales combine with other changes to produce more lasting emergent changes, creating a sort of temporal hierarchy of time windows that collectively alter the state of the brain at each given instant. The authors conclude that time is the only physical variable that's inherited by the brain from the external world. Thus, they say memories must be made of time, or more precisely, of temporal relationships between external stimuli. A new study claims the frequency of extreme El Nino events will increase during this century because of global warming. And it says those increases because of man-made climate change will continue even if temperatures are stabilised at just 1.5 degrees Celsius above pre-industrial levels. The research by the CSIRO and reported in the journal Nature Climate Change shows that even if warming was halted at the aspirational 1.5 degrees Celsius target from the Paris Agreement, the frequency of extreme El Nino events will continue to increase due to a continuation of faster warming in the eastern equatorial Pacific. Currently, the risk of extreme El Nino events is around 5 events per 100 years. However, that doubles to about 10 events per 100 years by 2050 when global warming increases by over 1.5 degrees Celsius. The research is based on 5 climate models providing future scenarios past the year 2100. The findings show the impact of man-made climate change on the El Nino Southern Oscillation, which is a significant driver of global climate. The most severe previous extreme El Nino events occurred in 1982-83, 1997-98 and 2015-16, years all associated with worldwide climate extremes. Extreme El Nino events occur when the usual El Nino Pacific rainfall center is pushed eastwards towards South America, sometimes up to 1,600 kilometres, in the process causing massive changes in climate. And the further east the center moves, the more extreme the El Nino will be. This pulls rainfall away from Australia, bringing conditions causing intense droughts across the country, and at the same time it also increases rainfall and storm activity across the Americas. Archaeologists have discovered a community of 2,500-year-old homes near Jerusalem that were destroyed by the Babylonians during the destruction of the first Jewish temple. The homes were discovered by scientists from Israel's Antiquities Authority and the Weizmann Institute on the eastern slope of the city of David in the archaeological park surrounding the old city. The homes were located just outside the walls of Jerusalem, buried under piles of stones, possibly belonging to other buildings that were also pillaged and destroyed by the Babylonians. Inside the homes, archaeologists have found large numbers of items associated with Jewish households of the time. They also found the usual clay pots, vessels for food consumption, remnants of fish bones and grape seeds, and numerous unique works of art. Among the vessels found were several stamped with the image of a rosetta, a rose with 6 petals. It's believed to have been a symbol associated with the government of the day, allowing tax collectors to keep track of harvests and supplies. Also discovered were numerous works of art in very good condition, including a sculpture made of ivory, indicating the high standard of living in ancient Jerusalem. The findings mean that the ancient Jewish capital was expanding well beyond the old city walls during the Iron Age. Previous digs in the old Jewish quarter have already shown how the area west of Jerusalem was expanding during this time, and the new findings indicate that the same was occurring on the eastern side of the city, where homes were also being built well beyond the city walls. Scientists have sequenced the genome of tardigrades, shedding new light on their origins and on the genes that underlie their extraordinary abilities to survive extreme conditions. Tardigrades are also known as water bears and moss piglets. They're microscopic animals, justly famous for their amazing ability to withstand complete dehydration, resurrecting years later when water is again available. Once desiccated, they can be frozen in ice, exposed to radiation, and even sent into the vacuum of space, and still spring back to life once you just add water. Tardigrades became more famous recently when it was suggested that their DNA was a mixture of animal and bacterial segments, making them sort of Frankenstein hybrids. However, the new study, reported in the journal PLOS Biology, which examined the genetic code of 2 tardigrade species, has now put that idea to rest, arguing that tardigrade DNA looks normal, with no evidence that these special animals use extraordinary means to survive. But of course, what's normal to a tardigrade is still enigmatic and exciting. Less than a millimetre in length, tardigrades are too small to leave fossils, but using the new genomes, scientists were able to explore what the DNA could tell them about where tardigrades sit in the tree of animal life. Tardigrades are a distinct type of animal, whose closest living relatives are arthropods such as insects and spiders, and nematodes like roundworms. But while their 4 pairs of stubby legs could make them look closely related to arthropods, the DNA evidence surprisingly strongly favours a closer kinship with nematodes. It was also possible to identify the genes that tardigrades used to resist the adverse effects of desiccation. Scientists identified pairs of proteins that appear to replace the water that their cells lose, helping to preserve the microscopic structure until the water is available again. And other proteins were found which appear to protect tardigrades' DNA from damage, and this may explain why they can survive radiation. And finally for now, next time you drop artificial sweeteners into your coffee thinking of the weight you'll lose by avoiding sugar, think again. A new study published in the journal Cell Metabolism has found that artificial sweeteners combined with a low-carbohydrate diet significantly increases the quantity of calories consumed. The study, by researchers at the University of Sydney, offered fruit flies diets with varying amounts of carbohydrates and sweeteners, and then tracked their resulting food intake. The flies that consumed artificial sweeteners alongside a low-carbohydrate diet showed an immediate increase in food intake. This increase varied according to the dose of sweetness provided and was not observed in flies consuming unsweetened foods. Bad news indeed. You're listening to Space Time. I'm Stuart Gary. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts, or Audio Boom. This has been another quality podcast production from Bytes.com.